Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about how you can view the derivative as a function itself. So in order to do that, we have to change how we view the definition of the derivative. So here we have the definition, which we have seen in the previous video, where you have f prime a and the expression on the right hand side given as such. And this is a derivative when a is just a constant. So here the keyword here is a constant. Now in order to create or in order to view derivative as a function, we need to make sure a becomes a variable. So a has to be a variable and not a constant. A has to be vary instead of a constant. And because of that, if you want to represent a as a variable, you need to choose another alphabet because we don't want to have a confusion over it. So now we are going to represent a as a variable, and we're going to choose another alphabet to represent the fact that it is not a constant anymore. Yeah, so we choose, for example, variable x. So x here will replace the position of a, and by doing this we have changed the view where the derivative now is considered as a function. Okay, so here let me reiterate again. If you have a function, this is a function. If you want to find the derivative, which is f prime x is also a function. And other notations for f prime x are given as follows, such as y prime. Y prime is quite common because really it is common to say fx equals to y, and so if you find the derivative of this function, it is common to use the notation of y prime to denote the derivative. Yeah, and other notation is dy dx and this one. So these two are quite common. I use it quite often myself. However, for these two given here, I seldom use it, but you might find these notations being used in some standard textbooks. So it is good if you are familiar with these notations as well. Okay. Alright, now let's look at the example here where you are asked to find the derivative of a function and the function is given as such. And so we are going to apply the definition which you have seen on this page. So this is what we're going to apply right now. And here we have f prime x. Here we have limit h approaches 0, fx plus h minus fx over h. And so I'm going to substitute x plus h into this function here. And what I'll get is, I will get 1 minus x plus h. Be careful with the negative and positive sign. It can be a bit confusing. 2 plus x plus h minus, so now I'm going to substitute x into this function, and really this is just representing the function itself. So it's going to be 1 minus x over 2 plus x. Yeah, over h. And there is no other way to simplify the expression except that you need to find the common denominator for this term and simplify that accordingly. So that is going to be a bit tedious, but let us just do this one bit, you know, take it one step at one time. Yeah, so here we have limit h approaches 0. So the common denominator for this one is definitely going to be 2 plus x plus h. So this is 2 plus x plus h times with 2 plus x. Okay, next on the top part here we have this one, 1 minus x minus h. 1 minus x minus h multiplied with 2 plus x. Here we have negative sign. So here we have 1 minus x multiplied with 2 plus x plus h. And over here we have h at the bottom part, and this is equal to multiplying with 1 over h. So now we are going to try and simplify the whole expression given here. So what we have now is limit h approaches 0. So here we have 2, we have plus x minus 2x minus x squared minus 2h minus xh. Okay, so that's this one. And here we have negative sign and we have a bracket. Okay, so for this one we're going to multiply all the terms. So we have 2 plus x plus h, and then we have negative 2x, we have negative x squared and negative xh. This is such a long expression. And at the bottom part you will have 4 plus 2x plus 2x plus x squared plus 2h plus xh, and here we have 1 over h. So now we are going to cancel out the terms that have similar terms with positive and negative sign. Yeah, so for example, you can see that this is a bracket. We are not taking out the bracket yet, so you can see that this is actually negative 2, which can be cancelled out with 2. Yep, and here is negative x, which can be cancelled out with positive x. And here we have negative 2x and negative, so this is positive 2x, can be cancelled with negative 2x. Here we have positive x squared, can be cancelled with negative x squared. And finally I have this one is positive xh, can be cancelled with negative xh. So here I am left with the term negative 2h, and here is negative h. Negative 2h minus h, it will be negative 3h. Okay, so let me just write down the simplified expression of that. So I'm just going to use this area. So here limit h approaches 0 is going to be equal to negative 3h over, so the bottom part here can also be simplified to 4 plus 4x plus x squared plus 2h plus xh times 1 over h. And clearly based on that you can cancel out h and h, and so you are left with this expression here. And if you substitute 0 into h, this will become 0 and this will also become 0, and so the final answer is going to be negative 3 over 4 plus 4x plus x squared. So this one is going to be 0, this is also going to be 0 when you substitute 0 into h, and this is actually negative 3x plus 2 squared. Okay, so that's the answer to this example given here. Okay, let's move on to the next example. So here, if f(x) is equal to this function, find the derivative of this function and then find the domain of the derivative. Is this domain smaller or larger than the domain of function f? Alright, so now let's start off with the definition, which is f prime x is equal to limit h approaches 0 fx plus h minus fx over h. So I'm going to substitute x plus h into this function. So I have x plus h minus 1 minus, now fx is going to be square root of x minus 1 over h. And in order to simplify this process, I need to be able to get rid of the square root sign. And in order to do that, I need to do some sort of manipulation. So how to manipulate the situation is by introducing something, or introducing the new term that doesn't change the original expression. So this is the original expression. And I'm going to introduce now a term that doesn't change this expression. And if you look at this term, it's going to be the same I term here, x plus h minus 1, square root of that. So the sign here is going to be switched to positive. You will see later on why I switched that to positive. This is x minus 1, the square root of that. And this here at the bottom is going to be the same exact term, which is going to be positive sign. This is x minus 1, the square root of that, okay? And by doing that, I hope you can see this is the same thing as multiplying this with 1. So this is the same thing as having value 1, because really this term can be cancelled out at the top and at the bottom. So you have the result is equal to 1. So by introducing something that doesn't change the original expression is what we call manipulation. So you manipulate the situation, yeah? Alright, so now let us try and simplify the process given here. So we need to multiply this part, the bottom part, with this 1, and the top part with this expression given here. So what you have here is you will have limit h approaches 0. So if you focus on the bottom part, you will have h multiplied with this expression, right? So you will have x plus h minus 1, the square root of that, plus the square root of x minus 1. So that's the bottom part. And on the top part here, if you multiply this with this, you will be able to get rid of the square root sign. And this is because if you remember the very basic idea of exponent, if you have square root of a, this, okay, times the same thing, square root of a, you will be able to get this equal to, if I write down square root is just 1 over 2, and this is also 1 over 2. And using the law of exponent, this is equal to 1 over 2 plus 1 over 2. And this is equal to a to the power of 1, which is just equal to a. So by multiplying the same term that has the square root sign, therefore you'll be able to get rid of the square root sign. And here we have the same term, which is x plus h minus 1, and this is also x plus h minus 1. So by multiplying these two terms here, the answer that you will get is x plus h minus 1. So you get rid of the square root sign. Right, next is if you multiply this term with this one here, notice that they are not similar. The terms under the square root sign are not similar. And therefore, if you multiply these two terms, it is similar like if you have square root of a times with square root of b. There is nothing that you can do. There is nothing to simplify anymore. You will just get the same answer. Square root of a times square root of b is going to be square root of a times square root of b. And the sign here is going to be positive. Okay, the sign is going to be positive. Now notice that if you multiply this with this, okay, this with this, you will have the same thing as square root of a times square root of b. You will have the same thing as this times this. Okay, if you multiply this and this, you will have the same thing as multiplying this and this. except that you have a negative sign. So it is something that it is something that you have negative a times with b, so you will get negative a times with square root of b. So because of negative and positive sign, the terms will be cancelled out, so we don't need to write down the answer to that because it will be cancelled out. Yeah, I hope you are following my discussion. And if you are not sure what I'm talking about, you can do the steps on your own, and then you will figure out that the terms will be cancelled out anyway. Okay, so here let us recall what we have done so far. We have multiplied this, and this is what we get. This and this is what we get. And if you multiply this and this, you will get a positive result. And if you multiply this and this, you will get the same result, but the answer is negative, so that one will be cancelled out. So now we have the last terms to multiply, which is this one and this one, yeah? This one and this one. So here, notice that the terms here are similar. So if you multiplied that, you will get rid of the square root sign, and you will left with x minus 1. Okay, so that's what's going on the top part. Okay, so next let us simplify the whole process. So it becomes limit h approaches 0, and x and x here can be cancelled out. Positive x, negative x, negative 1, positive 1 can be cancelled out. So what you have is you have h over h, x plus h minus 1, the square root of that, plus the square root of x minus 1. And of course h here can be cancelled out. And so what you have is limit h approaches 0, 1 over x plus h minus 1, the square root of that, plus the square root of x minus 1. And if you substitute 0 into this function, you will get this equal to x minus 1, the square root of x minus 1. This is plus the square root of x minus 1, and the answer that you will get is 1 over 2 the square root of x minus 1. Okay, so that's the answer that you will get. Okay, now you are asked to find what is the domain of f prime. So what's the domain of the result that you just got over here, yeah? Okay, so now the domain of f prime. What's the answer to that? You can see that this is f prime, and we know that f prime x is equal to 1 over 2 x minus 1. And we know that if you have a rational function, the denominator part cannot be 0, so that is something that you need to consider. So therefore, we know that x minus 1 cannot be equal to 0, that's for sure. And we also know that x minus 1, the inside of this square root sign here, must be something that is not negative, or else you cannot obtain the square root of a negative values, right? So here we have what we have is we can consider x minus 1 to be a value that is greater than 0. Okay, so here, based on that, we can consider x minus 1 to be a value that is greater than 0. Therefore, x must be greater than 1. Okay, so domain is x, where x is greater than 0. So you can check if, sorry, not greater than 0, x is greater than 1. x is greater than 1. So you can check if x is 2, this answer is going to be a positive value, and you can find the square root of it, and it is not going to be equal to 0. So if x is 1, if x is equal to 1, 1 minus 1 is going to be 0, square root of 0 is going to be 0, and we will have a problem here. So here the domain of f prime is going to be this one. X must be greater than 1. Now if you compare this with the domain for fx, here the domain for fx clearly x minus 1 can be greater than or equal to 0, and so x is greater than or equal to 1. Because if x is equal to 1, 1 minus 1 is 0, square root of 0 is 0, so we have no issue with that, as long as the inside here is greater than or equal to 0, yeah? So for this one, domain of fx is x, where x is greater than or equal to 1. And based on the answers given here, you can see that the domain of f prime, here is smaller than the domain of f. Okay, so the answer here is therefore the domain of f prime is indeed smaller than the domain of f. Okay, that's all for now. Thank you very much for watching.